All right, in this problem, we're trying to find the area of the region bounded by these two graphs. In order to find the area of the regions, what we need to find are intersecting points of those regions, or of these two graphs, rather. So the intersections are going to happen whenever x cubed equals x. Common mistake that's made here is dividing both sides by x. We don't want to do that. What we do want to do is subtract x from both sides, giving us that x cubed minus x equals 0. Factor out an x. We have x times x squared minus 1 equals 0. Factoring the x squared minus 1. Hopefully you recognize that as the difference of squares. We get x times x plus 1 times x minus 1 equals 0. And that tells us that x could equal -1, 0, or 1. And those are the places where these two graphs intersect. Now, drawing a quick sketch, which is frequently helpful, I know that y equals x squared is going to look something like that. I'm sorry, not y equals x squared, y equals x cubed. And I know that the graph of y equals x is going to look something like that. Actually, nothing like that, because it's not even close to being equal. There we go. It's a weak graph, not pleasant, but I think we'll make do with it. That's one of our regions. This is the other region. When we try to find the area of these two regions, first of all, I know that's -1, this is 0, and this is 1. What we'll do is we'll integrate from -1 to 0, but we have to do the topmost function minus the bottommost function. And in this case, in this interval from -1 to 0, the topmost function is y equals x cubed, and the bottommost function is x dx. In the other region, we're looking at the integral from 0 to 1 of the topmost function is now this red graph, or just x, and the bottommost will be x cubed dx. Well, you should be able to integrate these fairly painlessly, and we'll be looking at 1/4 x cubed minus 1/2 x squared, evaluated from -1 to 0, plus, and in the other integral, we'd be looking at 1/2 x squared minus 1/4 x to the 4th, evaluated from 0 to 1. When I evaluate these terms at 0, I'm going to have 0. But when I subtract off these two terms evaluated at -1, oh boy, this should be a 4th here. My apologies. When I evaluate these at -1, I end up with 1/4 times -1 to the 4th minus 1/2 times -1 to the half, or to the second. Likewise, in the second part that we're going to evaluate, I start with the 1, and I end up with 1/2 times 1 squared minus 1/4 times 1 to the 4th. And then when I subtract off these two terms evaluated at 0, that's just a 0. And I'm doing a lot of steps here, a lot of steps I probably wouldn't do if I was doing this problem on the AP exam, but maybe more steps are better. It's all up to you. It's depending on your comfort level. I'm going to go ahead and take the brackets off. I'm going to get rid of this 0. I'm going to get rid of that 0. I have 1/4 to the -1 to the 4th, or -1 to the 4th power is going to be a minus 1/4. Distribute the negative, giving us plus 1/2, plus second term now, 1/2 minus 1/4. Combined terms, 1/2 plus 1/2 is 1. -1/4 minus 1/4 is minus 1/2, giving us a final answer of 1/2. So the area bounded by these two regions here, region 1 and region 2, is going to be exactly 1/2.